Question 9 is a exponential equation that we're supposed to solve. So this can be solved in this couple of different levels. I'm going to go with the first level that I think is probably the easiest way to thinking of this. Since I have a 1 over here, 1 I can change into a base 5 fairly easily. 5 to the 0 power is equal to 1. So if I get the representation of 1 is equivalent to 5 to the 0. If the bases are the same, then the only way the expression will be the same is if the exponents are equivalent. So that means 3x minus 1 really has to be equivalent to 0. So 3x minus 1 equals 0, which means 3x equals 1, which means x is a 1/3, and we would be done. If you don't recognize that right away, we can come back to what we talked about this year. If it's an exponential equation, and you want to solve it, we can undo exponents with logarithms. So we could take a natural or common log of 5 to the 3x minus 1 equals the natural log of 1. Use our power rule. The log of a power is the power, 3x minus 1, times the log, which is natural log of 5, natural log of 1. And then we could divide by the natural log of 5. So 3x minus 1 equals the natural log of 1, divided by the natural log of 5. And then we'd have to add our 1 and then divide by 3, or I'm going to take this whole thing and multiply times 1/3 to get rid of multiplying by 3. So x is equivalent to the expression I have here, natural log of 1 divided by the natural log of 5 plus 1 times 1/3. And that should give you the same thing. So here's why it is. The natural log of 1, what is the exponent I raise e2 to get 1? Well, that is 0. So it's 0 divided by something down the bottom here, which I really don't care about because it's going to be 0. And 0 plus 1 is 1, and 1 times 1/3 is 1/3. Now you can plug it in your calculator and do that if you'd like. But there's two different levels of which you can work that. Certainly this one method on the left that I showed you is much quicker than the method on the right. But we also have another method that we can use.